So what's going on, guys? DIY Dan here, and this is another mechanical video. In this video, I'm going to be working on a 2014 Chevy 2500 HD with a 6.0 gas engine in it. Now this truck was throwing a couple codes. One was a P0119, engine coolant temperature sensor 1, circuit intermittent or erratic, and a P0118, engine coolant temperature sensor circuit high voltage. Now on this vehicle, it ended up being an intermittent problem caused by a bad wire. However, before figuring it out that it was a bad wire, I did end up replacing the sensor, so I'm going to show you where that is, how to replace it, and how I did the wire repair. And I'm also going to go over some of the symptoms that might happen if you have this problem with your truck as well. So let's get to it. So most of what I talk about in this video should apply to most 6.0 liter gas engines that are in Chevy vehicles between the years of 2014 and 2019. Now, because this ended up being an intermittent electrical problem, I was getting codes for it running too hot and too cold. Before condemning the sensor for anything running too hot, you do want to check the basics of the cooling system, including a radiator cap that's not holding pressure, a thermostat that's sticking, an engine cooling fan that is not working properly, or any possible leaks like hoses or the water pump that are causing you to be low on coolant. Another very common issue that I see get missed a lot is just dirty radiator fins caused by excessive idling or vehicles being on job sites that are sucking a lot of dirt through the radiator. And all that needs to be done to correct that problem is take an air compressor and blow that dust and dirt and leaves out of the radiator. So right here you can see that while this was going on with this vehicle, the check engine light was on. And because it was an intermittent problem with wiring, there was a couple different things happening with it. The first one is, most of the time, the temperature gauge would not read above that 160 degree mark. And that was because most of the time this thing was running, that signal was not coming back from the sensor because of that cut wire. Now that temperature gauge might fluctuate or jump up and down from normal temperature all the way down if you do end up having an intermittent wiring problem like I did. One of the things that ended up happening with this vehicle was it had a very erratic idle and wasn't running worth a crap. And one of the reasons for that is it uses the engine coolant temperature sensor to judge and what to do with the air-fuel ratio, basically. So right here you can see on my scanner that I'm reading negative 40 degrees on the engine coolant temperature. So the PCM thought this thing was super cold and giving it an air-fuel ratio to try and warm up when it was already at running temperature. The other thing that might end up happening if you have a wiring problem or a temperature sensor that's gone bad is an engine hot, AC turned off. And this is basically to protect your engine. If it thinks it's running hot, it's shutting off the AC so you do not cause damage to the engine. So those are some of the symptoms you might end up with. Now let's get into where this temperature sensor is and how to replace it. And I'm going to show you how I did the wire repair on it. So hopefully you're in a position where you can do this when the engine is cold. I, however, could not because I was in a rush. So right here I am very slowly loosening the overflow cap to relieve the pressure in the coolant system. The engine coolant temperature sensor is right on the driver's side cylinder head right in front of the exhaust manifold. To make the sensor easier to get to, I removed the spark plug wire off of number 1 cylinder. Make sure you twist the spark plug wire to break it free from the coil and the plug before pulling on it so you do not damage the wire. Once getting that number 1 wire out of the way, I was able to pull back the heat shield that protects the sensor and wiring and then unclip the pigtail off of the sensor. So here is a little better view of that sensor and its location. You'll notice how close it is to that exhaust manifold, which is probably why this is a pretty common problem on these 2014 Chevys. Now at this point, I did not realize I had a bad wire on this pigtail. So I went ahead and replaced the sensor. So right here, guys, I'm going to re-emphasize one more time that I am working on a hot engine, and I do not recommend doing this at all. If you do have to do this on a hot engine, make sure you protect your hands and arms from possibly getting burnt. It's also a good idea to drain the radiator out before doing this. I didn't have that option because I did not have enough coolant to refill it. And I was in kind of a time crunch, so I went ahead and just tried having quick hands. It didn't go too badly, but it could have gone better. After getting the new sensor in, I went ahead and put my spark plug wire back on. Went ahead and topped off the coolant. A funnel might have come in handy in this situation. And I went ahead and fired up the engine, and I still had nothing reading on my temperature gauge. And the engine was still running erratically. So then after that, I started investigating my wiring a little better. I pulled that connector end back off the sensor, and that's when I realized I had a severed wire right by the pigtail end. So an easy repair for this would just go online and get a repair connector end. They're not that expensive, and then you can just butt connect and heat shrink these back together. However, I wasn't in a position to do that, so I had to repair this one. So the first thing I did is took a pick and removed the gray part of this connector. Then I pulled the rubber seal off using the same pick and unsnapped that purple part of the pigtail end. Then using a small needle, I depressed the little metal clip that holds that wire into the plastic connector and pulled the wire out the back. Alright guys, since it was kind of hard to see on the actual pigtail itself, I just broke this down so I can show you how to remove these pins out of this connector. The brown part here being the connector, and the green is the pigtail end, and these are your wires going out. So what I did with that needle is push that in and collapse this part of the wire end. Once collapsing that, it fits under this part of the plastic connector, and then you can pull the wire out the back. Then I removed the electrical tape and the plastic wire loom off of the wiring harness to give me enough slack to do the repair. I stripped the insulation off of the wires so I could use a butt connector to do the repair. I do like to use butt connectors that don't have the insulation on them and then use heat shrink over the top of them. By using the uninsulated butt connectors, it allows me to use a smaller piece of heat shrink, and I do like using heat shrink because it helps with vibration on that connection point since we had to repair it. Once getting the butt connected together, I went ahead and grabbed a small piece of heat shrink, put it over the top of it, then using a lighter shrunk that heat shrink down to collapse it around the repair. Before reinstalling the wire in that pigtail end, you want to leverage this part of this tab back up because it tends to get flattened out when you pushed it down in the connector. So you just want to get under here with a needle or a small screwdriver and pry this up a little bit and put it back at a little steeper angle. So when you push the wire back into the connector, that little tab sticks up, and make sure it catches so it doesn't eventually vibrate and walk out the back of the connector. Once pushing the wire back into the pigtail end, I went ahead and put the rubber seal back over the pigtail and then snapped the purple plastic back on the end to hold everything together. Because the repair was so close to the connector end, I could not put that gray plastic piece back on the backside of the connector. So using some electrical tape, I taped those wires up, then put the wire loom back over the top of that and taped that up as well. I did that on both ends of the wire loom, then plugged the connector back onto the sensor, then pushed the heat shield back over the top of the sensor and the connector. So after it was all said and done, I went ahead and cleared the codes out of the scanner, removed the check engine light from the vehicle, went ahead and fired it up. Noticed that the temperature gauge was working correctly now, and I was getting a reading on the scanner, and that the AC was working correctly now. Now keep in mind, if you did drain the radiator in order to do this sensor, that make sure you get all the air pockets out of that cooling system. I like to fill it completely up, get it up to temperature, let it cool down one more time, and then make sure it is still topped off in the overflow container. Hopefully you guys enjoyed this video and it gave you some good information. If so, make sure you hit that like button and subscribe if you haven't already. I'd really appreciate it. The whole concept of my channel is to give you guys the most information in the least amount of time as possible so I don't waste your time. And I hope to see you next time. Have a good one. Later.